Hello, my name is Nestor Bermudez. I'm studying System Engineering at Unitec Honduras, and I'm currently working on my graduation project. So let's talk about that, my graduation project. What I'm looking with this project is to help computer science and system engineering students to understand the concepts and some abstraction related to hardware design and things that you see in classes like computer organization or logical design. Okay, let's talk about the application now. This is a desktop-like application which is actually not finished. This is what I have so far. I have like 2 more months to work on this, and let's give you an overview of this application. We have some menus here, a file menu in which you can create 2 types of windows. We'll see this is a design window, and you can have a simulation window too. Let's talk about features of the design window, this one. Okay, here you have some tabs on the left, design preview and source and error log. This one, the source, is used to write Verilog code. So if you are not familiar with it, you can get some book or something. So you define your hardware component logic or behavior using Verilog. This is why Verilog is a hardware description language. So let's make a dummy module. Input rec A, input rec B, output rec C, and let's assign C equals to A plus B. Change this is actually another without overflow or other things. Okay, so in this window you have some other options. You can compile this Verilog source, and in case there is errors, it should be shown here. Let's try that one. Yep, it's a syntax error because we are missing a semicolon. And when it's actually successful, it generates what we could call a chip. This chip has 3 ports, which are the ones that I define in the module, and you can play with them. So here you have, and this is all the design window is. This design, you can save it. Let's say other. One requisite is that it's like Java. You must name the file after the module name. So it actually generates 2 XML, one for metadata and the other for the actual logic, which is this and the preview. Okay, this is all you can do here, and other utilities like clear logs and just the preview after compiling. And that's all for that window. Okay, now let's talk about the other kind of window, which is simulation window. I'm gonna close this and open a new one to be able to load the recently created module. Okay, let's talk about this. We have a file menu with a save and close options, and since this is a simulation window, you can add module components defined previously on a design window, or primitive components like AND gates or any kind of gates actually, inverters and some kind of inputs and outputs, also wires of course, and a multiplexer. So let's add some gates, for example an AND gate, and you can make it larger, move it around and things like that, and you can put some inputs in it, high input, another input connected to this, and it generates a 1 as an output because it's high and high, and you can double this. Okay, and you can add, okay, let's see, an inverter. You can also select and move around or move everything, and okay, and you can also add a module. Let's add another module, which is the one I defined previously. So you just click it and here it is. This one has an input A, input B and output C, and you can also connect inputs to it, or move this and add a wire, that's okay. This is supposed to reflect the output here, depending on the changes on the inputs, which is not completely working. It's working just for 1 bit signals, which we will see. I have this other module, a test module that I made previously, which is actually a register file, and it can receive a clock signal and other values. You can add a wire, so let's put it here. Okay, and this is it. That you can pause the simulation here, and of course if you change something, it doesn't reflect the changes, it doesn't propagate the changes until you press continue. Okay. You can also save this and load it later through this open option. And another feature, which is actually the most important, I think, of this project, is a watcher or debugger, like most IDEs, most IDEs have, like NetBeans and Visual Studio. So you can right click on a module component or module sheet, as you want to call it, and it displays the list of variables that are inside this module, and you can select or deselect them, and you can click this add watch, and this window is a summary or are the watches that you define for this component. Actually, if you have another component, let's say this one, you could add and say okay, and it added in the same window. And you can also delete from here or delete all, re-added. Let's see, okay, clock, red number. And this is actually working. You can, let's see, let's connect it to clock and change this to high. And it shows that the value is actually 1 now. Okay, if you double click in the module sheet, you will get the source code of the module if it is a leaf module, which means that it doesn't have module instances inside it. And if it's not a leaf, it should display like a drill down view of the module, which is not implemented yet, so sorry for that. Okay, what else? Oh, okay, we also have a settings editor. This is like something I took from Eclipse, which is you set like a workspace, and that's where you save your module definitions and metadata, and also some options like for people that wants to extend this project, things like the book mode, in which you, okay, it's important to save first, and which displays the bounding boxes of some elements to check if there are collidings and things like that. And it also enables a lot of outputs in the NetBeans console or the standard output console. Another feature like keep elements connected, so if you have this enabled and you try to move this, it doesn't deattach. And another thing, show logic values. Instead of showing an H for high and an L for low, it shows an 0 or a 1. In case someone wants to extend this and apply it to non-discrete components like AC sources and things like that, you can define what is gonna be a low voltage and a high voltage, the repaint pause, and something that it does apply only for the text editor for Verilog. So let's see if we change it to dark and we open a new design window. Okay, that's the default, and okay, there it is. And the color scheme changes. It's not actually important, but some people like the black screen, so. And that's pretty much everything I have to show. Any recommendation is welcome. As I said before, this is an ongoing project, so it's not finished, and I hope you find it useful. And as I said, any suggestion is welcome. Thank you.